Hi, here we have another question from Iran Math Olympiad year 1997, round number 1. So the question says that we have an isosceles trapezoidal ABCD which is inscribed in a unit circle, a circle that has a radius of 1. And suppose that M is larger than N, M is GC, N is GB, and the question is to find M minus N. Here I wrote it M minus N is equal to AB because it's the first page, but in reality, the question was a multiple choice question. You had a number of options. You have to choose what the value of M minus N is equal to. First round of Iran Math Olympiad usually consists of multiple choice question. You have 30 questions for 3 hours. So for each question, you get approximately 6 minutes. So maybe I spend 5 to 10 minutes, try to solve this exercise and then come back and see the solution. All right, so let us see the solution. We're going to connect the segments OC and OB, and then we look at the angles that we have in this figure. So for example, let us look at the angle BGC. This is an inscribed angle, so it's equal to the arc BC plus arc AD divided by 2. But because we know that ABCD is an isosceles trapezoidal, so we know that the arc BC and AD are equal. So basically arc BC plus AD divided by 2 is equal to arc BC. Okay, now we look at the angle BOC. This is a central angle and is in front of arc BC. Therefore, this angle is equal to the arc BC. So based on this, we can say that the angle BGC is equal to BOC. Okay, so we have already proven this. Because these two angles are equal, then we know that the quadrilateral GBCO is an inscribed quadrilateral. So this is what we conclude. For an inscribed quadrilateral, we have a very famous theorem. It says that if ABCD is an inscribed quadrilateral, we take AB multiplied DC plus AD multiplied BC is equal to AC multiplied BD. So if we multiply the opposite sides and then add them together, that is equal to if we multiply the diagonals. We know this theorem and I'm going to prove this after this slide. And we are going to apply it for this case. So we take the quadrilateral GBCO and we apply this theorem. Of course, the two opposite sides, A multiply B plus N multiply OC, but OC is equal to the radius, so it's R. So AB plus N times R is equal to M multiply OB, but OB again is radius, so it's R. And then we can take NR to the other side, factorize R. So AB will be equal M minus N times R. And because it's a unit circle, R is equal to 1. So M minus N is equal to AB. So for this exercise, the correct answer is option C. Okay, so now I'm going to prove the theorem that we have used to solve this exercise. We have an inscribed equilateral ABCD, and we want to show that AB multiply DC plus AD multiply BC is equal AC multiply BD. This is what we want to prove. Of course, because this is inscribed quadrilateral, we know that, for example, angle BAC is equal angle BDC. Or we know that angle ADB is equal to the angle BCA. Okay, this is what we know. We're going to add an extra point, an extra line in this quadrilateral to help us solve the theorem. So we select point K on AC such that the angle CBK, this angle is equal to the angle ABD. So these two red angles should be equal. Okay. If you have this one, we can say that the triangle ADB is similar to the triangle KCB because this angle is equal to this angle and these two angles are equal because we selected K in such a way that this angle is equal to this angle. Okay, so if these two triangles are similar, we can write the ratio. For example, AD divided by KC is equal to BD divided by BC. So AD divided by KC is equal to BD divided by BC. Okay, because of this, we can say that AD multiplied BC is equal to BD multiplied KC. This is first point. Again, we can say that triangle ABK, so this triangle is similar to the triangle DBC. These two triangles are also similar, and we can write the ratio. They are similar because this angle is equal to this angle, and this angle is equal to that angle. So therefore, these two triangles are also similar. We can write the ratio again. For example, AB to DB is equal to AK to DC. Okay, so we have this one. We can multiply them together. AB multiply DC is equal to BD multiply to AK. Now, if we add these two equations together, the left side is basically AB multiply DC plus BC multiply AD, and the right side would be BD multiply KC plus AK is AC. So BD multiply AC. So we have proven the theorem that we have for an inscribed quadrilateral. Yeah, the technique that we have learned is basically this theorem. Whenever you see an inscribed quadrilateral, you know that if you multiply the opposite sides and add them together, that is equal to the multiplication of the two diagonals. All right, so that's the end of the video. See you next time. Bye.